Hello, we are in section 5.4. Now we're going a little farther with logarithms. We kind of understand logarithms. Logarithms are exponents. There's some nice properties of logarithms, and now we want to formalize that, the properties of the logarithms. Now, a good place to go would be to go to your modules and make sure you know what the logarithmic properties are. If you go to modules and go to chapter 5 and scroll down a little bit, you'll see a PDF file. Now, this is actually a lecture that I've given before, and you can download it. These dates are for another class. Obviously, those are spring dates. But anyway, right here are the exponent definitions, or exponent rules, or laws of exponents. And I guess these are more of the definitions. These are kind of the laws of exponents. Things like if you multiply like bases, you add the exponents. Or if you multiply and raise a product to a power, that power hits both the A and the B. So these are some things that you probably need to work through if you haven't done it before. But this is what I wanted to point out, is the properties of the logarithms, and this is what we're going to be using in this section. So these are what they are, and I'll try to illustrate them as much as I can during the homework over here. Okay, let's hit our first few examples. Number 1, so it just says the log base 3 of 14 times 11. Now that dot looks a little weird, but they want to distinguish it from 14 decimal point 11 for sure. It says expressed as a sum of logarithms. So one of the properties of logarithms, the sum, the log of a product turns into a sum. It's a weird property. It's referring back to that if you have like bases and you multiply them, you add the exponents. Remember, logarithms are exponents, so you're adding the exponents coming out of that product. Okay, back to the homework here. So this is going to be log base 3 of 14 plus log base 3 of 11. It's a very unusual property. The log of a product is the sum of the logs of each factor individually. Very, very unusual. All right, next one. This is a logarithmic property. The base is weird here. It's n, and then what's inside is z to the 6th. And so it just says express as a product. And what they mean is get that exponent outside of that logarithm. So the log rule is that you can pull the 6 out front of the logarithm and just do the log base n of the base z. This is very handy. This is a trick we use quite a bit, and we really need this property. So it's based off of it's this one right here, the power property, that R come outside, and it's back here, a to the m to the n. If you look at this one right here, it's the product of the exponents, m times n. That's what we're seeing here in this inverse property one. Because remember, logarithms are exponents. R is an exponent, so we're taking that exponent r, and we're multiplying this exponent that's associated with the log of m. All right, so that's number 2. So it's just 6 log base n of z. No, it looks crazy. This is log base 3 of 14 plus log base 3 of 11. Next one says express as a product. Again, you just you bring the exponent outside and you keep the other stuff as is. Express as a difference. So the logarithm of a difference is that's another log rule. So here we go. So we have a quotient. You start with a quotient, and it turns into a difference. It comes from the quotient of 2 exponents and have like bases. You subtract the exponents. That's exactly what we're doing here, is we're subtracting the exponent associated with h from the exponent associated with 4. All right. Now 5 has a couple things going on. We've got a product, and things can be pulled out, turns into sums. So let's just jump right in there. So the first thing to note is that we have a product between these three things. So immediately you can say log base b of x squared plus the log base b of y to the ninth. So the dot looks in a weird spot there. Plus the log base b of z. All right, now we don't want to stop there. It says rewrite as a sums or difference of logarithms. I think they're going to want us to go a little farther. By the way, I've included the answer key at the bottom here. We're on number 5. And so number 5, they want you to go a little farther. See how the 2 is in front of this, the 9 is in front of that? They want you to pull that out. They want you to use both logarithm rules. So the logarithm of something with an exponent, well, the exponent can be pulled out and dealt with like that. That 9 can be pulled out and put out front. And then nothing going on with that. So the log of a product is not the product of the logs, it's actually the sum of the individual logarithms. All right, great. Let's keep going. This is the natural logarithm. Now, the logarithm of a quotient can be written as the log of the difference. So take the log of each piece and then take the difference. It looks like they want us to keep going. So this ln of 9. This is a product here. Be careful. It's not a base 5. So minus, and the things are going to distribute here. Got to be careful. Let's go ahead and pull that 5 out. I mean, there's no reason to leave that in there. And there you have it. Now, whether they want us to distribute this negative or not, not really a big deal. But on number 6, I'd say the final answer would have been with the negative distributed. So like that. Final answer on number 6. Number 7, we're actually going in reverse. So how many more do we have here? Let's take a break here, and we'll come back and do the rest of them. Hey, thanks for watching.